Hello students, today I will discuss Lagrange's interpolation formula. I am taking n plus 1 points, means from x0 to xn there are n plus 1 points, and having this n plus 1 points I will construct the Lagrange's interpolation formula. Actually I have already written the formula here. See, this whole is the formula from here to here. So Lx, I have written the formula like Lx is equal to x minus x1, x minus x2, and so on. So here see, I have written the table for n plus 1 points x0, x1 to xn. There are the value of fx, which is actually y. The values, corresponding values are this. So for this n points, how to write the Lagrangian formula? Lx, here Lx is a polynomial, and for that we have the formula like that. First of all, take x0, this is the first point, and see, except this x0 I have written all the remaining points, x minus x1, x2 minus x2, x minus xn up to x minus xn, and this is the upper part or numerator, and in denominator I have written the same as written in upper part, x, but instead of x I have written x0. Okay, so this is our numerator, and in denominator we have written x0 minus x1, here x minus x2, so x0 minus x2 dot x minus xn, for that it is x0 minus xn, into x0's corresponding value of fx is fx0 into fx0. This is the first term. The second term is we have to take the second point x1. So except this x1 I have written all, means x minus x0 into x minus x2 dot dot x minus xn. Here I have written that in numerator, and in denominator just put x1 instead of x in numerator, then you will get the denominator part. You can see the symmetry of this pattern and into the corresponding fx1. Similarly, for third point x2 I have excluded this point, and in numerator I have written x minus x0, x minus x1 dot x minus x3 actually dot dot x minus xn, except x2 I have written all, and in denominator it is I am taking x2, x2 minus x0 dot x2 minus x1 to x2 minus xn into the corresponding fx2. Like that, continuing this pattern, the same pattern I have written for xn. In case of xn, the same I have written, except this xn remain all point you have to write like x minus x0, x minus x1, x2 dot dot x minus xn minus 1 by xn minus x0, xn minus x1 dot xn minus 1 here into the corresponding value is fxn. So this is the our last term. So this is the basic formula of Lagrangian formula. Now we'll go for an example, then it will be more clear to you. Students, I have written the example, a sum using Lagrange's interpolation formula. Here we have to find out the Lx. Okay, this is a polynomial. As I said, in this formula it is Lx, so here also we have to find out the polynomial, means the Lx, for 1 2 3 4, for this 4 points. Okay, so solution. First of all, first I am writing x0 is equal to, this is x0, x1, x2 and x3. So all I am writing here, and x3 is equal to 3. So, and we have this fx0, fx1, fx2 and fx3. We have to write this also. So I am writing 2 if x3, x2 is equal to 11 and if x3 is equal to 34. So this data we have. Now the Lagrange's formula. For 4 points. Previously in this general formula we did for n plus 1 points, and here we are doing for 4 points. So what will be the formula Lx? So first we have to exclude x0, so x minus 1, x minus 2 into x minus 3. So x minus 1, x minus 2 and x minus 3 by what? 0 is the x0, so 0 minus 1, 0 minus 2 and 0 minus 3. 0 minus 1 and into fx0. What is fx0? 1 into 1. Similarly, the second term will be x minus x0 into x minus, I am excluding the x1, so x minus x2 means 2 and x minus x3 by 1 minus 0, 1 minus 2 and 1 minus 3 into fx0, fx1, as it is for x1, so into 2. The next term it will be x minus x0, x minus x1, and I am omitting the x2, so x minus x3 by the x2 was 2, so 2 minus 0, 2 minus 1 and 2 minus 3 into fx2, that is 11, plus the last term x minus 0, x minus 1 and x minus 2, as I have excluding the x3, which is 3, so x minus 0, x minus 1, x minus 2, the last term, and the x3 is 3, so 3 minus 0, 3 minus 1 and 3 minus 2 into our fx3 was 34, so 34. Now calculate this here, minus 1 into minus 2 into minus 3, minus plus into minus means minus, 3 to the 6, so it will be minus 6 the denominator, and here also you have to multiply and we'll get a result. Similarly all term you have to calculate, and the simplified form will be, here is the first term, it is the first term, on simplifying I get this, the second term on simplifying this I have this, and this is third term and this is fourth term. When you calculate the whole you will get this, and finally after all calculation means here x cube, how many x cube? 1, and the final here minus x cube plus 6x cube. Just gather together the all x cube or similar term, means x square, x cube, all this, and finally we'll get this kind of, on simplifying you will get this. And when you are omitting this bracket, 6 into 1 by 6 gives 1, so 1 into x cube. Here also 6 into 1 by 6 x square, 6 into 1 by 6 1, and here also 6. All 6 are vanished by 1 by 6. So this is our final answer, and this is the LX, means this is the polynomial. So our polynomial is this, like that. And if you have if you are to find out the L, suppose L1 in question, then just find out this. After that put 1 in place of x, so 1 cube minus 1 square minus 1 plus 1. So what will be the answer? This is the will be the final answer. Here we have to find out the polynomial only, but there are many cases when you are to find out L1, L2, L3, L0.2, some numerical value will be given, and actually the one example here you can see that you have to find the value of f2. This is actually L2 and f2 is given. So first of all you can see that I have calculate the LX, first LX. After that I have put in the 2 as a value of x, so f2 is equal to 2 cube plus 3 into 2 square. Instead of x you will put 2. First this is actually our LX or fx. Then first you are getting the fx. After that you will get the particular value when it is required. Hope it is clear to all of you. If not, let me know. Okay, thank you.